some of your assessments and stuff? Okay. All right, so let's go over the components that a dishwasher, not only the components of the dishwasher, but some external sources that have to be in place for a dishwasher to operate properly. Somebody that was here and heard it, give me one.
120-degree water temperature.
Water temperature, 120 degrees. Why?
Activate the enzymes in the dishwashing detergent.
Okay, all right. What else? Raise your hand. So just go ahead.
150 degrees to activate the enzymes.
Bleach.
If you're using the pod,
Okay.
there's detergent and bleach in that. The 150 is to be activating the bleach in the pod. That lets that pod open up and the bleach go in. That's done in usually like the final rinse cycle when it heats up the water by itself. Right? What else do we need?
We need a good resource, the proper high loop,
You need a proper loop in your drain. For what reason?
so it doesn't, the siphon effect doesn't bring water back to the bottom of the dishwasher.
Okay. And maybe some odors from the garbage disposal if it's hooked to one? Yeah? Okay. Anybody else? Yeah?
Water pressure?
Water pressure, we need to get the right water pressure into it, and it should be between what?
20 PSI?
And what's the optimum? What's the best? Where would we like? Around 60, something like that? Okay. I know I just bought a new RV, and I got the RV, but I had to go out and buy a water pressure regulator, because if that RV gets any more than 60 PSI in it, it blows all the hoses out of the thing. So I had to buy a separate pressure regulator, so when I went to an RV camp, you know, you don't know what their water pressure is, so I had to do that. So that was interesting. But what else?
Power source.
Power source? Voltage?
Has to be.
Voltage? Voltage?
You need
Runs
one-
120 volts? Okay, yeah, we need proper voltage.
Needs to be on its own separate brick.
Separate breaker.
Own separate
15 amp,
circuit. What amperage size?
Between 15 and 20.
15 or 20? 15, I think is what it calls for. That
Right.
surprises me. That you, little Johnny, you think it'd be on a 20 amp breaker pretty much?
The standard for most homes is 20,
Yeah.
20 amps, but a dishwasher only requires 15.
It'll work on, definitely work on the 15 if they got it.
Yeah, I'll definitely work on 15 because they usually run 8 to 12 volt, 12 amps. That's still within the 80 percentile range, so.
Yeah.
What's the biggest draw?
Anything else?
We want the water to be between, what was it, 20 and
Water pressure.
150? No, for the water softness, not to be too hard and not to be too soft.
Yes, we need to know, we need to be able to know how much detergent to use, and the little pods is kind of measured out for you, because that's kind of an average of most houses around the country and stuff. If they're using powder or liquid, they gotta be a little more precise about what they're using based on their water hardness and things like that. Okay? How do they know what their water hardness is?
We can test it.
Some people know because when they turn their faucet on, it pings the porcelain off their sink. So yeah, it's pretty hard water. But there's test strips that you can buy. Maybe their water company that supplies water to them knows how hard their water is. There's another little test kit. It's kind of a mad science kit that you put little drops and it changes the color of the water. But water hardness is important because water hardness is calcium. Calcium builds up, creates issues, you know, in the hoses, in the filters, you know, just all kinds of stuff. You're missing something. You're missing something that's really important.
You wanna make sure it's level and not, yeah.
Level, certainly. Why? Can't just tell me that. You gotta tell me why.
So the water doesn't drain towards the front, it comes out the door gasket.
Right.
Slightly back is better than level.
Slightly back. Slightly back.
Gotta use the rinse aid.
There it is, rinse aid. It is not nice to use, it is a must to use. In today's dishwashers, that the water temperatures are down, the heating element wattages are down, all those things. Softener, let's say fabric softener. Don't put fabric softener. Rinse aid is a must, and they must use it. And if there's an objection to it, You're just gonna have to explain to them, you're gonna have less than optimal drying results if you do not wanna use rinsing.
In the book, is a must.
It is. Well, it doesn't punch them in the face, but it tells them
It is
that
required.
pretty strongly that it's required to use a rinsing. Yeah,
And because of the Energy Star standards, that's when that all started changing,
yeah.
and that's why the development of rinse aids came out.
What rinsing does is it makes the water slipperier. It's like you waxed your car and then you see the beads of water. That's what rinsing does. It reduces the tension on the dishes and lets the water run off and starts cheating action, actually starts the drying motion, the drying of the dishes. And it helps out. Okay? Are we good on what the requirements are and all those things? So, again, we had some different models back there. Some had AC pumps in them, which means they run off 120 volts, and you guys checked those and got resistance readings of them, correct? I think there was only one group that worked on the water wall, and it has some different components in it. It has a DC drain pump motor in it. Now, what's different about a DC motor and an AC motor as far as checking it?
Common ground versus proven neutral. I mean, common neutral versus proven ground.
I'm just talking about checking the resistance of the component itself. Your meters, the voltmeters that we have are not designed to check the resistance of a DC motor. First of all, it may have a little printed circuit board inside it. There's probably 120 volts being supplied to it, and you're going, oh, it's 120 volts. But there's a little board inside of there that converts the AC to DC that actually runs the motor. Okay? DC motors are more efficient, they run quieter, they run cooler, all those types of things. So that's why DC motors are used in a lot of the upper end type equipment that you see. So just a more efficient, gives them a little better energy ratings, all those types of things. But you cannot check the resistance of that motor. I think it was 21 ohms on the ones that were 100 AC. Couldn't do it on the DC motor. Little different deal there. Also, just a reminder, whenever you're checking resistance or continuity, you have to isolate the component that you're checking by unplugging it from the electronic control board. At least one side, I prefer both sides. And then you go across that component and check it for resistance or for continuity. Okay? They all have some kind of a pump or motor or whatever they call it. They call it different things on the schematics that circulates the water, that forces it up into the spray arm, right? Some kind of a motor or system that does that. Okay? The water valves on units that have a triac. You guys all know what a triac is? No. Okay. Triac is an electronic switching device. It's mounted on the electronic control board. Okay? It creates a gate voltage, it closes a circuit and allows power to flow. If you look at your schematic and you see a symbol with 3 little legs on it like that and a triangle, that's like that's a triac symbol. Did you go over symbols yesterday, Johnny? Or?
We have not gone.
Okay. So anyway, that's a triac. If you have a triac in a circuit and it's sending 120 volts to, say, the water valve, if you do not have the water valve hooked up to that, you will not get 120 volts. You need the load of the component for the triac to react properly to send 120 volts out there. So if you pull that wire off and check, you will not have 120 volts if it's triac operated. Okay, that's something that drives people crazy. Drives people, they'll go, I don't have 120 volts, I don't have 120 volts, the badge board bad. Nope, nope. Plug it into the water valve, and then make the check. Anything else? Why do you get so quiet? Jeez, I just asked for another question. Come on. You're thinking? Oh, that's why it's so warm up here.
I got a question.
Yeah,
You were saying that DC is more efficient,
yeah.
so can we attribute that efficiency and all the benefits with that because it's not alternating? Like,
You mean the alternating current as opposed to DC current?
correct.
I don't know.
You want him?
Is a DC motor more efficient and run cooler because it's not alternating current?
That is true.
It is true.
A direct current keeps it more steady and more even as it rotates. But then again, AC current, you can do the same thing with capacitance, because that capacitance takes that sine wave that you normally see in the AC current, and it levels it out. Okay, it smooths it out. Capacitance will do that, yes. It's the same thing within a microwave. When you're looking at the capacitance, you need a more level AC voltage in the capacitance so that it makes the same sound wave. It makes more steady sound waves so that that microwave will actually cook.
Okay.
Okay?
You can get that same level of efficiency and stability in either or, it just depends on the application.
Just depends on the application. A lot of those AC motors will run really loud and whine really loud.
Yeah.
But if you turn it into a DC motor using a variable frequency drive and run it off a DC circuitry, then you line out that sine wave to a straight wave, and it'll actually quiet that motor down and still run as effectively, if not more efficiently.
Wow.
These are all little teeny ways of reducing the energy usage. Y'all see those yellow stickers on appliances? If they can move that arrow to the left a little bit, they get all kinds of things from the government, you know, because of reducing energy and, Energy Star and all these.
That's where Energy Star and everything
So-
comes in on these appliances, is due to that stuff right there.
They may be just looking to move that one notch.
The other benefit of a DC component is when it gets an irregular algorithm or current draw, the logic in the board will often cut power to it based on that overloading of that circuit. So like Samsung has what you call switch mode power supply, that it will sense that irregular current draw, and then it cuts power, so it's less likely to short out the board. That's one of the benefits that like the consumer-based electronic companies like Samsung and LG brought to the home appliance industry, because they started doing a lot of that technology, because they use that in the CE world. And so, you know, a lot of times, like Greg had mentioned earlier, a lot of times Whirlpool used to do a monitor board returns, and you'd have to return them, and they found so many of them weren't the problem. Okay, and same thing, Samsung's done that, they've all done their studies, because if it's stress, it quits sending the signal. And this is like what you'll see the triac up there too. And I remember having to get a board authorization from Whirlpool, and they were fighting me, and I had the water valve hooked up. A lot of people disconnect alternating current loads, because then it's easier to get to. You got a dishwasher installed, you're reading in on the backside, as you're going like this, it's hard to get into your to get to your component. So it's easier to disconnect it and read your AC to it, except when you see that triac, you can't do that. And you'll see, usually you'll see the board breakdown, and you'll see those two reverse triangles. When you see that, that's a triac. So then if you check that load, if that's feeding that output from the board to that component, you must have it hooked up, okay? Whenever you see that. So an example for anybody who's OEM, who's gonna be OEM, when you work on OEM stuff, GE had an issue where you would get there, so guess what happened? It just shorts out a brand new board. Yeah, because they don't have that regulation in their feed from the board. You know, so that's the difference of what like switch mode power supply will do for you.
Okay, dishwashers, we're good?
Good.
No redos, no go backs, no putting parts on for no reason, diagnosing properly. I'm done.
Okay. Thank you.